two different disciplines, I suppose, going on. The difference when we're talking about cross-country courses is that actually this surface is very well, very often it's not managed in the same way, and obviously it can't be. You can probably see on this little picture that I've got on the left-hand side that we've got a horse. This is a four-star event, and in the UK. This was held in October, so it was in the fall in the UK. And you can see that there's undulating ground, big fences, galloping downhill, and actually then crossing different types of road tracks that might be placed within the course. So you've got this sort of difference in ground condition, and you can see the horse in the middle as it's taking off. That of course there's a little bit of number of divots, and the ground is likely to change as the horse goes round this the course. I mentioned that the horses would be going around about 9.5 meters per second. They're covering around about 6 kilometers, so that's 3.8, 3.9 miles in gallop over a number of solid fences. So they're negotiating through quite often quite complicated combinations of solid fences. And when they're competing in this kind of discipline, they actually have to compete or get to as close as possible to an optimum time. So at this top level, with these sort of figures that I've just given you, they're looking at around about 11 minutes. So they're competing for around about 11 minutes at gallop over solid fences. And what we're particularly interested in is not necessarily looking at the surface just before and after a takeoff over a fence, or indeed maybe if there's a road crossing that's bisecting the track, but we're more interested in that the turf that the horses are galloping over, be it that's nearly 4 miles of gallop, and actually near the end of the course they're bound to be tired. We know that the horse will fatigue, and we're interested in actually the impact that surface has on the way that the horse is running. And so that's what we're particularly interested in. And I think understanding a little bit about the demands of the horse and the speed that they're actually running at is quite important. So that kind of gives you a little bit of I suppose, a heads up in terms of thinking about what we're going to look at today. I'm going to start off by talking to you about current management techniques that we've got in place. I'm going to talk to you a little bit about some of the work that we've actually carried out over the last, it's been 2.5 years now actually, in order to develop a suite of tests that are able to assess cross-country tracks. I'll talk a little bit about some of our initial findings, and I'll also talk about our current protocol and where we're going in the future with this. Particularly over the last probably 12 to 18 months, we have been doing a little bit of work testing turf racetracks as well in the UK, and indeed we've got the equipment is going to be used next week at the Cheltenham Festival. They've actually requested that we come in and do some testing every day, so prior to the races starting, and this is really to just give us a better understanding as to what we're measuring, what data we're getting, and how close that sits with what they're seeing at the moment. So in terms of going forward, I think this work that I'm talking to you about cross-country tracks actually extrapolates into any kind of equestrian activity that is involving turf surfaces. So I think, again, because this is a live session as well, we'll very much look forward to questions at the end if that's possible. So yeah, please do ask questions at the end. I'd be very happy with that. So just to sort of start off by talking a bit about some of the management techniques that are being used, and indeed to think a little bit more about the types of surfaces that are involved in or are used for cross-country competitions. We're looking at a huge variety of different types of turf. We're looking at so different types of grass species, and actually different types of ways that surfaces have been managed. So we have some events that are on it's old estate land. We have quite a lot of events on something that I would call amenity grassland, whereby for much of the year they're probably used for other things, and that might be cross-country training events. It might be actually dog walking. It might even be people coming out and picnicking. It might be parkland. So there's a variety of different kind of uses of the turf surfaces that we use for cross country, which of course is very different to thinking about racetracks. And you can probably see in these two images that I've got showing you here, the one at the bottom demonstrates a very different type of turf to the one at the top. And indeed, horses at the top end of the discipline will be competing on a variety of different types of terrain. And indeed, this is part of what the competition is all about. So, we don't want to be able to manage these surfaces to a point whereby they're totally uniform and that actually everything is pristine. That's never going to be possible, and that's not really what our aim is with understanding more about how we assess the surface and how we manage it. It's more about making sure that actually we do the right thing, and I think we have a duty to the horse to make sure that we are indeed at least objectively measuring this surface so that we can indeed then maintain it in the most appropriate manner. And you can see with the image at the top here that we've got a bowser actually irrigating this track. It was unfortunate. I actually tried to capture this bowser going in the other direction further on at the track, and actually because the wind was blowing and because it couldn't quite get to right to the track, actually all the water ended up at the side, and so none of it went across the track itself. But of course, this example is a great example of whereby the irrigation has worked. But when we've got these types of cross-country courses, they're actually being carried out over a number of different fields. Quite often they'll be managed in different ways. So you might have some parts of the track that are on grazing land, so land that's used for livestock. But then there might be other areas that perhaps are not utilised as much for maybe different types of stock, and they might be kept a little bit a bit better. And I guess probably what I'm saying here is that we've got lots of different surfaces, lots of different types of management techniques, and lots of different uses really for these different tracks. And so actually what happens in terms of the way that they're managed will vary from course to course. When people are managing, so when track managers are managing the surfaces, some of these events will only occur maybe 2 or 3 times in the year. And actually, as the run up to the event occurs, the track managers will be observing and assessing the surface. But invariably, that's still very subjective. So actually, from all the places that we've been testing over the last couple of years, we haven't really identified any specific equipment that's being used to give any kind of objective measurement. And so, this is really kind of, I guess, in some ways a surprise, because if you think about any type of sports surfaces, they're invariably going to be assessed quite significantly and quite extensively throughout the year at this level of competition. So the management obviously will depend upon the way that they manage the surface, will depend on the track conditions, track use as well, certainly environmental factors, and also resources that they've got actually to hand. So this example at the bottom, this track at the bottom, is one that actually only opens up several times a year and is then managed quite intensively for 2 or 3 weeks prior to the big competitions. And this indeed was one of the big competitions. This track was actually, the photo that I've taken here was, I took it in the afternoon. So the track had been, the competition had started around about 8 o'clock in the morning. And this was, I think, probably only about 2 or 3 in the afternoon. And there was still a lot of horses still to go. So we're probably about 2/3 of the way through. And examples like this, of course, it's really important that the surface holds up. And this surface actually was quite variable that day. So it was quite interesting to be able to see there were some areas that were particularly soft. There'd been quite a lot of rain prior to, so I think 2 or 3 days beforehand. And of course, all of these factors are going to make a difference as to whether or not the track managers are going to be aerating or irrigating the surfaces. And pretty much aeration and irrigation are the two kind of main techniques that are used. But of course, as I've just mentioned, actually the observations or the way that these surfaces are assessed are pretty much subjective all the way through. And I guess to that end, I suppose what I'm saying is that there's no standardized method of being able to assess cross-country ground condition at this stage. And of course, that's something that we're quite interested in changing. So from everything that I've just said from the previous slide, I guess, you know, it's really important to be aware that actually what we can measure, we can then manage. And at the moment, tracks are managed, but they're not necessarily being measured. They're being observed, assessed, or subjectively assessed, but we haven't got any measurements. And so this project that we're working on at the moment is essentially we're trying to develop a suite of tests that are realistically going to be able to be used over approximately 6 kilometres of undulating track. And that's something that actually, again, we don't necessarily want a really complex piece of equipment, because indeed the logistics it's just not going to be possible. You can see on the left-hand side the image of the Arona biomechanical surface tester, which I think probably most of you will have heard a little bit about yesterday if you were listening to Lars Ropsdorff and Oliver Hoberg. You would have heard a bit more about assessing the surfaces at Tokyo. And of course, this equipment is often what we describe as gold standard, because it simulates a horse's fall and landing on the surface. It tells us a lot about actually what the horse will experience, but it's not realistically, it's not necessarily something that we're going to be able to get round all of the cross-country courses that indeed we have in the UK. So for the top end events, then yes, absolutely. But actually in terms of logistics and also the method of being able to assess these surfaces in order to be able to manage them properly, we really want to develop a simpler suite of tests. So some relatively simple pieces of equipment that we can use, we can actually carry with us. So if we're on foot, we can carry them with us. You can see an example here. So on the top right hand image, we were lucky enough to have a gator a vehicle to be able to actually take our Arona biomechanical surface tester around. But down on the bottom image, you can see two of my very good colleagues were actually, we've ended up using harnesses to be able to drag this, particularly when the ground or the going was undulating and we couldn't actually use any vehicle. And this was, this was actually at the beginning of the day, not at the end of the day. I'm probably glad I didn't take a photo at the end. We were all pretty tired. But in terms of thinking about, you know, the practicalities, this is not something that's going to be possible in the long term to be able to carry out these routine tests. And so really our idea with the work that I'm talking to you about today is this idea of developing relatively simple suite of tests that we can then use to measure cross-country going and then allow track managers to be able to prepare it most appropriately. So the idea being that we actually take measurements prior to the competition. That might be the night before, it might be several days before, and then actually they can prepare it in the most appropriate way or target certain areas. The other idea is that actually this is something that we will eventually be able to post prior to the competition, so that riders actually have information about how the going is and actually can then prepare accordingly. Some of you might be aware, but with any rider riding cross country at the top end of the sport, so the elite riders and horses, they will use traction devices in the horse's shoes. So they'll use screw-in corks or stud shoes to be able to provide them with a little bit of extra traction. And actually, if they know a bit more about the condition, then that's going to help them make those decisions. So I've sort of alluded a little bit to the rider and actually the horse. And I suppose one of the points that we mustn't forget about in relation to measuring the surface is also thinking about how the horse what the horse experience is and how the surface or our measurements translate to the horse and of course to the rider. So with our project, with the work that we're doing at the moment, we're actually managing to get round, and so you can see an image here on the right hand side. I'm surveying or questionnaring one of the riders immediately after the cross country course. So at all the 3- and 4-star long events that we go to, the riders actually have to stay around to have the horse inspected by one of the vets that are officiating at that event. And so at that point, we can actually capture their attention once they've seen to their horse. And I've been very successful in being able to get rider opinion of the surface. And I'll talk a bit more about that on the next couple of slides. So Obviously, we want to know about the objective measurements of the surface. We want to know how we can measure the surface, but we also want to know what the rider feels and how the rider experiences that surface. And then it allows us to be able to look at that data and compare it and understand a bit more about what's going on. One of the interesting, I suppose I describe it as a bonus really to all of this work, and I hadn't anticipated that this would occur, but with this, obviously with the questionnaire work, we're providing, we're giving the riders that opportunity to become aware of what we're doing. And so riders, trainers, owners, vets are all becoming much more aware of this work. And actually, you know, we've just honestly had positive sort of buy-in from everybody that we've been working with. So this sort of questionnaire work has actually given us a little bit more, I suppose it's helped us with this study. So I mentioned just now the idea that actually we want to know a bit more about how this, how the surface or how the surface, how the horse responds to the surface and what the surface means to the horse. You know, we can use very simple pieces of equipment which might tell us something about the surface, but that doesn't necessarily tell us directly what is important for the horse for that surface. And that's where the Arona biomechanical surface tester comes in and provides us with some really useful information and some very important information about the surface. So it begins to, or it helps us understand a bit more about what the horse is experiencing. And so I've got a couple of slides just really to put what I've just been talking about into context. And I've used, you can see the little reference at the bottom, but this is the Equestrian Surfaces Guide that you can find in the FEI literature, so online. And these little images of the horse are found in that guide. What I've done underneath each of these, so I'll talk a little bit about the different functional properties. I'm starting off with impact firmness, but underneath each of them, I've actually just pulled out the scale that we've used to actually get the riders to tell us how the surface feels to them. So for instance, with impact firmness, we're actually asking the riders how soft or how hard the surface is. And with these visual analog scales, we've essentially, they're 10 centimeters long. The rider will put a line or a mark on the scale, and then we can measure them. So we've got a sort of an objective, as it were, as objective as it can be, but we can take a measurement of what how the rider perceives the surface to be. So I've started off with impact firmness, and actually I'm talking on this slide just about the top layers of the surface. So impact firmness is all about when the horse first lands on the surface, and actually we're particularly interested in this in relation to thinking about things like I mentioned irrigation and aeration, and actually understanding a bit more about hardness of the surface is quite important when we're considering the types of management techniques that might be used. So of course, things like aerating the surface or irrigating the surface will make quite or can make quite a significant difference to that top layer of the surface and the impact firmness that the horse will experience. The other functional property that is quite important when we're considering the top layers of the surface is grip or slip. So for the rider, we ask the rider how slippery or how grippy the surface is, whether it's high grip or whether actually it's quite slippery. And this is all about when the horse's hoof lands in the surface and starts to slow, and also it relates to that idea of when the horse is moving forward and that propulsive phase as it moves forward into the next stride. When we're looking at grip, we're talking first of all about the interaction between the horse and horse's hoof and the surface, but we're also very interested in actually the interaction between the different particles of the surface. And if you remember, you know, I was talking about cross-country surfaces being quite varied, and quite often you'll find bits of stone or tree roots, etc., within the surface. And of course, you know, that adds to the variation of the surface, and of course that's not necessarily something we're wanting to measure generally, but these kind of I suppose variation that we might see might be something that the rider might pick up on. We're very aware with the rider assessment, the perception of the rider. Quite often they will be biased towards the areas that are extreme on that track, but at the same time it's actually quite an important element of what we're trying to assess here. So not only the top layers of the surface are important, but it's also thinking about perhaps the deeper layers of the surface. And might actually probably be quite a good idea to add that with these little images that you've got here on each slide, these images are actually describing, so the sort of layers of the surface. This actual schematic comes from sand and fibre surfaces, but I think what you can do is perhaps sort of imagine thinking about a turf surface, and of course that's more about the different layers of the turf surface and then the soil as you go down and as you go deeper. So the cushioning is actually all about all the layers of the surface. And again, with the rider, we would tend to describe that as between, is it deep or is it compacted? And again, of course, this when we're thinking about the horse, it's during that mid-stance phase where actually the maximum force of the horse is loaded onto the surface. And of course, the surface is either able to absorb and dampen that or not, depending on how deep and compacted that surface is. And the last one that I just wanted to kind of mention really here is the responsiveness of the surface, and thinking about the elastic energy that can be recovered from that surface. And we describe this for the rider as to how dead or active that surface is. So how much it gives back to the horse. It's not just about the elasticity or the elastic energy from the surface, it's also about the timing as to when that's given back. And of course, if that's at the moment when the horse is moving forward into the next stride, then that's going to be of benefit to that horse. And you'll feel the horse travel more easily across the ground. When we talk about this sort of elite or top end of cross country, the horses are ordinarily quite tired when they're getting towards the end of the course. And so if you've got a course that actually is helping the horse, that's very much something that a lot of the riders are sort of very aware of when they're riding, when they're discussing how the track actually feels and how it translates to the horse. So in view of all of this information, I've given you a slide here that just talks a bit about the simple tests that we've developed, because I've talked a little bit about the Arona biomechanical surface tester, but I wanted to give you a bit more information about some of these simple equipment that we've been using. And I've started off on the left-hand side talking a bit about the penetrometer, and I'll come back to that just in a moment. But just to sort of mention that the criteria for these pieces of equipment that we wanted to develop were really that they needed to be manageable. They needed to be, in terms of logistics, we needed to be able to carry them on foot, or actually indeed on a little electric scooter. You can see the middle image. We've got we've actually started using Mark Lucy, my good friend and colleague, has actually been doing a lot of the work using this little electric scooter, which he's adapted with a little box on the back. So it allows him to sort of whiz around the course and do the tests and actually get everything collected relatively quickly. This is obviously really important if we're testing just before the event. So very often we'll get to the competition and actually we've probably got 1 or 2 hours to test, and then the track managers want to know what's going on and what the track seems to be like, so that they can go and target any areas and manage them most appropriately prior to the competition starting the next day. Every now and then we might be starting off testing very early in the morning just before the competition starts, and so being able to be quick is really important. Obviously it needs to be a reliable measure, and of course we need to make sure that actually this relates or correlates to our gold standard equipment as well. So the Lang penetrometer and the Longchamp penetrometer are two pieces of equipment that we have been kind of keen to actually trial. This is very much all about soil strength, and essentially what you're measuring the force involved in pushing that penetrometer into the soil. So it's basically a metal rod that's pushed into the soil. And the Lang penetrometer is the one we started off with. I know that a number of us had a discussion about whether or not this would actually be appropriate. It's really easy to carry. It's small, as you can see, but it is used manually. So you actually have to, the user has to push it into the ground. And actually what we found with our data that we've analysed over the last couple of years, that it doesn't correlate particularly well to all of the rest of our data, and certainly the OBST. So that one has been taken out of the mix. I might add that we've had a couple of other pieces of equipment that we have used originally, which are now taken out of the mix as well. The Longchamp penetrometer, of course, is actually it's not it's not influenced by things like, for instance, the user that's pushing it into the ground. And that's great. One of the other things that we found with the penetrometer is that very often in this type of surface, you get little bits of stone and actually maybe cracks in the ground. And indeed, if the surface has been aerated, and you get obviously different readings. And so that can actually sort of skew the data that we've collected. So at the moment, we've got a question mark at the Longchamp penetrometer. We're not using it currently, and that's partly because of the logistics of carrying it around. So I'm just going to talk a little bit about the Vienna surface tester, and I've got a video in a moment, so I'll show you that, and it'll probably help you understand a bit more as to how this works or how it's dropped. But essentially, this is actually an instrumented bowling ball. And it was designed by colleagues of mine from the Veterinary University in Vienna, Austria. So it's Professor Christian Paham and Dr. Peter Schrammel have designed this piece of equipment that is instrumented to provide us with information about stiffness and hardness of the surface, and also displacement and energy restitution. So we drop it at a number of different heights. It automatically detects height, and therefore we're able to measure then speed. So we can calibrate it at different heights to then provide us with a really good understanding as to what's going on the surface, with respect particularly to impact firmness or hardness, and also stiffness of the surface, which relates to all of those layers of the surface. So that relates quite nicely to cushioning. At this stage, again, we're still in early days of collection, but we're quite excited about what we've seen so far with this piece of equipment. And obviously, one thing that we're missing with this piece of equipment is actually understanding a bit more about shear resistance of the surface. So, sorry, I'll give that one a tick. So Vienna surface tester is definitely in the mix. And the next one that we've got in the mix is the shear vane tester, because this is actually telling us more about shear resistance and perhaps thinking about the grip of the surface. And otherwise, we're actually missing any piece of equipment that's helping us understand a bit more about that. We're only using this year, so sort of watch this space, I guess. And of course, the last measurement is moisture content. We want to know about moisture, and we measure this with the TDR. So it allows us to, so it's time domain reflectometry, and allows us to measure volumetric water content. So that's a tick as well. So I've got a little video that I'm just going to show you. It's sped up just to sort of time lapse to just give you an idea as to how we collect data. This is actually at Blenheim International Horse Trials. So nice backdrop. So this is us bringing the OBST in. We've got the Vienna surface tester right in the middle, if you can see that. So it might be quite interesting to watch that. We've got the penetrometer, long penetrometer being used. We've actually got the going stick and then moisture meter. But if you can see, the Vienna surface tester is dropped at a number of different heights that then provides us with a number of readings that allow us to understand a bit more about what's going on. So soil samples that we are also collecting take a little bit longer, and I'll mention those in a moment. So just moving on then, from all of these pieces of equipment that we're using, we're able to characterize the course. So we're systematically sampling. We're collecting data at every 250 meters. So that's equivalent of about 270 yards. So we're getting a decent amount of data from the course. And actually this allows us to map our data and understand a bit more about what's going on. And you can see down on the left-hand side, we've got a little map that identifies, because we're using GPS, we can identify where all the samples are taken. And this is really useful, particularly for track managers. And then you can see on the right-hand side, we have a little, so we basically record the data and actually record the raw data that then brings up this nice little record for, or information for the track managers. And as I say, potentially in the future for riders and trainers, team vets, etc., to be able to actually have a look at prior to the event. So you can see in this example, I've just given you a little example here that there might be a few areas that perhaps, because we've color coordinated it, it's quite easy. They sort of stand out, and it allows us to understand a bit more about whether or not there's areas that perhaps might be slightly out of range. We're not suggesting that certain measurements are appropriate or not at this stage. It's more just giving some figures and giving some data that then allows people to be able to go and have a look at specific areas around the course and then manage it accordingly. Coming back to that idea, well, what we can measure, we can manage. So alongside all of these measurements, I mentioned a moment ago that we've been collecting soil samples, and of course I've mentioned already, but the moisture content as well is quite important. So just as a sort of a kind of last point really in this talk, I wanted to just highlight the fact that actually soil analysis and collecting soil samples we believe is really important, particularly for this early work. Certainly it wouldn't be something that we're expecting to be doing in the long term, but it is providing us with some really relevant information. So from the soil, we're doing some very simple analysis, but just really trying to understand relative proportion of sand, soil and silt within the surface, and all of this information about the soil texture tells us a lot about how the surface is going to respond. It's not really telling us or predicting risk or performance, but it is telling us how the surface will respond according to various maintenance techniques. It helps us determine water carrying capacity, aeration, porosity, permeability, bulk density. So all of these kind of factors I think are really important. And our idea at this stage is really just to be able to map the soil types at these events. And actually, if we can collect this data and we can then model it against our functional properties, it's going to be quite useful in the future. And again, obviously very beneficial when we're making decisions on the type of maintenance that's going to be conducted. So we just use a little soil auger. You can see me down on the right hand side. There's a little image of we keep managing to get some nice shots with some lovely old estate land in the background, which sort of makes it a bit more interesting. But yes, this is me collecting a soil sample on one of the tracks. So I mentioned just now on the last slide the idea that actually we can model our soil sample data against functional properties, and I'll talk a bit more about that. And I've got a handful of slides to just show you some of the data that we've got so far. And in relation to these graphs that we've collected data on lots of different tracks, but this is just a snapshot. So, and this is a snapshot to give you an idea as to what we've done is we've correlated our data with these very simple pieces of equipment with the Arona biomechanical surface tester responses. So the first one that I've got here is the impact firmness, which we talked about a moment ago, and we've correlated impact firmness with our simple tests. So we've basically developed or calculated a coefficient that's based on these simple tests that we've taken. And we find that actually there's quite a nice strong correlation, or at least moderate correlation, between impact firmness and these measurements that we've been taking. And then if we add a sort of a little bit more information to this, if I color coordinate this, you can see actually we've got some clusters going on in relation to that soil texture, which of course gives us a little bit more understanding as to how we're going to manage these different surfaces or maintain these different surfaces. And I've got the same thing looking at grip. So again, we're thinking about the very sort of top part of the surface, and of course, it's not just soil texture that's important here. It's also a variety of other things. So we might think about things like the sward quality, and so when we're talking about the top level of the surface, it can't just be related to the soil. We need to think about the sward as well. If I can just bring your attention to this little graph here. So looking at the correlation between grip and also our range of measured parameters. So we're looking at a range of measured parameters. They're slightly different for each one, of course. And again, we've got quite a nice correlation here. And if I color coordinate this, we've got, so just in terms of soil texture, we've got a few clusters going on here too. And I mentioned just sward quality just now. Of course, as I say, the soil texture is important, but it's also important to not forget that the sward or the grass that's actually recovering that soil is quite an important element. So I'm surprised that we've got such nice clusters actually from such small data set, but it's quite nice to be able to see that. And the last one that I've included just on this slide here is cushioning. And again, we have quite a nice relationship going on, and we've got these clusters of different types of soil texture. So I'm going to just move on to my sort of final slide that just talks about next steps, because I'm very conscious that I want to leave enough time for Mike to be able to talk a bit about the work that's being carried out, or the initial start of work in the USA as well. So our next steps for this project are certainly to refine this protocol during the 2022 eventing season. So it's sort of kicking off around about now and runs right through till October next year. This year. We're then going to analyse this ground data and the rider data, and we hope that from that we can begin to finalise a suite of tests that can actually be used to start assessing cross-country tracks and provide relevant information to those that need it. I've actually just added just a final comment about the idea of assessing turf racetracks as well. As I mentioned earlier, we have started doing a bit of work looking at racetracks and indeed looking at some very high profile events, for instance, the Cheltenham Festival next week. Obviously, this kind of equipment is all about measuring turf for equestrian disciplines, and so I think extrapolating what we learn here and then using it for other disciplines is a good way forward. So before I finish and before I pass over to Mike, I just want to make a big kind of heads up and thank you to actually all my colleagues who, without these people, Dr. Rob Graydon, Dr. Sarah Hobbs, Mark Lucy, Dr. Jamie Martin, Professor Christian Payham, Professor Lars Ropsdorff, and Dr. Preeta Schrammel. I know you've heard from Lars Ropsdorff yesterday, I think it was. But all these team members have been absolutely integral to this project actually getting to where we've got to at this point. A big shout out, I think, to Mark Lucy, who's done an awful lot of the data collection for us. And I'm going to finish on that, and thank you very much for your attention. And I'll stop sharing my screen at this point now, I think. Thank you very much.
Thank you, Alison.
Thank you, Alison. I'm Mike Boekholder. I own Boekholder and Associates. Until 2 weeks ago, I was the Director of Field Operations for the Philadelphia Phillies for the last 19 years. My background is actually in professional baseball. I've had a 30-year career in that program. When it comes to horses, equine sports, as I told somebody last night, my experience is about this. If you're on the southbound end of a northbound horse and he raises his tail, get out of the way. That's kind of what I know about horses, so take it for what it's worth. I'm going to talk a little bit today about diagnostic testing at the Fair Hill facility in Maryland. I got kind of brought into this process 2 years ago because I happened to do business with a company that does some installation and construction work in the Philadelphia area that I had a previous relationship with, that they went out and they were actually hired to sod the new tracks at Fair Hill when they rebuilt them 2 seasons ago. So give a little bit of a history of what's going on out at Fair Hill. They just finished about an $8.5 million, I believe, renovation of that facility. They have a 1 mile oval. They have a timber track that they use for steeplechase, I believe. And then they have the 5-star eventing course that kind of wanders off and meanders back through the back field. So I was actually brought in as part of a subcontract to do diagnostic testing on the grass oval and the timber track. The state of Maryland, which owns the facility, put that in their original contract when they subcontracted out the maintenance of this. And this is a great example of how a lot of these big projects usually go, unfortunately. They put in the money to go ahead and renovate it, and when Matt Wimmer from Hummer Turf, who was hired to install the sod, he's about halfway through the job. He finally looks up at the project manager for the Maryland Stadium Authority one day and says, "Just have a quick question for you." And the guy goes, "What's that?" He goes, "Who's going to take care of this when we get done laying the sod?" And the guy looked at him and says, Good question. I don't think anybody's bothered to ask that yet. So they scrambled, hurried up, put out a contract on it to get the maintenance done at this facility. And Hummer Turf ended up bringing in a partner of theirs, and they, along with Rupert Landscaping, for the last 2 years have maintained the two courses. Part of that the state required was then to also have diagnostic testing done, which is how I got pulled into this, because I had been doing some independent consulting work in addition to my normal job. And Matt asked me if I'd be interested in doing it. So I said, hey, we'll give it a shot. It's been very interesting. So the diagnostic testing is required only on the oval and timber tracks, which is kind of the funny part about this conversation, especially with what Allison's been talking about, because the biggest event they have out there is the Maryland 5-star that ran for the first time this year. So we'll get to that in a minute. What we did in 2020 was in 2019, we were taking moisture, shear vein, and clegg readings on the track. We also were doing this last season in 2021, we went ahead and added the Longchamp penetrometer to the mix at Mick's suggestion, actually. And we can talk about what I think about those two things just in my limited experience on this. But just for those of you who haven't perhaps are familiar, I mean, Allison covered this real quick. That's the Longchamp. This is the clegg hammer that we started out using, our TDR 350 moisture meter. And then this is our shear vein unit that we're using. The protocol we developed on this, out of no particular reason, was we take 3 readings every half furlong on the oval track. We actually marked out the timber track on half furlong distances as well. We take readings on the inside, the center, and the outside of the track. On the Longchamp, we take 3 readings per location. So with the clegg and the moisture sensor, we just take 1 reading at each spot. We actually drop the Longchamp 3 times and give an average reading of each area, which seems to give us the best data that we can come up with. We move that Longchamp every time. We don't do multiple drops in the same exact hole, if you will. We use the same protocol on the oval and the timber tracks. It's a shot of the front stretch there at Fairhill. Basically, what we've been doing at this point is gathering data sets. Really haven't been doing much with the analysis side of it. Unfortunately, you hand all this data to the state of Maryland and they go, hey, that's great. I have no idea what to do with it. So that didn't make a whole lot of sense to myself. Didn't make a whole lot of sense to Matt over at Hummer. So that's when we started reaching out to Mick. And he was kind enough to put us in contact with Allison. And now that process moving forward is, what do we do with all this data? What does it actually tell us? This track has only been breezed on 1 time so far. That was last fall. They breezed on it for about a half hour. So it's pretty much in pristine condition all the time. It's pretty neat to walk out there and see it, because it's just not something you see very often. The Maryland 5-star ran this last year, October 14th through the 17th. From what I can understand of it, a huge success for them. It's an Ian Stark designed course, has 45 obstacles on it. It's almost 4 miles long. It's only one of 2 5-star events in the United States and one of 7 in the world. Again, we got kind of drug into this as mostly sports turf guys, myself and the guys at Hummer. Really had no idea how any of this goes down or even what it was all about. It was fortunate that this year we were able to kind of see how that all worked, and we learned a lot just by watching the event. It's pretty interesting. It really is interesting how they go about doing this. This is a shot of one of the areas that probably 3 months earlier, Allison talked about improving conditions on the course. This is what's called an area of the course called Grammy's Run. This had virtually no turf cover in it going into May of last year. And we undertook a pretty aggressive seeding program back in here with the fescue and a little bit of bluegrass mix. And pretty rapidly, we're able to get this up to the point where Mr. Stark, when he came in, this was an area that he'd identified early on the course that he wasn't happy with. They actually had to bring in a portable water tank, set it up at the top of the hill. We're able to run this with a gas-powered pump and water cannon system to get enough moisture in this area to keep that germinated and get it up and growing. And by the time they ran in October, that was actually in really, really good shape. So this coming season, what we're hoping to do, working with Alison and her team over in England, is to go ahead and initiate a consistent set of testing protocols on the course for 2022. Our contact with the state is very agreeable to us expanding the testing protocol and actually modifying what we're doing on the front two tracks right now. We find that we're developing a lot of data sets that we don't think are really going to be very useful. So we're kind of narrowing down our focus on what we're doing on the oval and on the timber. And we're going to shift some of our resource time to going back and actually doing some data collection on the actual 5-star course, which again, as I previously said, those of us that got drug into this didn't really understand what was going on out there completely at Fair Hill until we've watched it go down for a year. Now we understand this is actually probably the biggest event that they host there. So putting more of our resources and our time to doing the diagnostics on the eventing course is actually something we feel pretty strongly about that's important. So what we're looking to do this year, I think, speaking to Alison the other day, is we're leaning towards going with the shear vein unit, the Longchamp penetrometer, taking the moisture readings, and probably bringing that Vienna equine surface tester unit into the mix. And if anybody asked me, no, at no point in time in my life did I ever think I would have to purchase a electrified bowling ball to do my job. But you know, you learn something every day, I guess. We're going to try to closely follow those protocols that they put together over in England to make sure that we're gathering the same set of data that she's gathering. Because as I said, this is all completely new to me. So having me sit down and try to analyze this stuff is a little pointless, but I do think we can collect that data, put it together with what the team over in England is doing, and should come up with some pretty good stuff. I know we talked about a little bit yesterday. Mick and I were talking about when we're down the arena floor. One of the things we're considering doing is actually running the big unit, the OST. I always forget what we call that thing. The OBST unit. Yes. Running that around and using that as a baseline basically on the course at some point, so that we have that baseline data that we can then go back and compare the more portable equipment that Alison spoke about and I just talked about as we move forward. Because I think what we're going to find, it's kind of like the Longchamp data. You can take that Longchamp penetrometer out on a course and you can drop it and you can do your thing. But the numbers that you're gathering, from what I understand so far, on any given track really are going to be unique to that track. So for the reports that I send in the state of Maryland for the purpose of the discussion today, we actually were able to come up with the range, if you will, that the Hong Kong Jockey Club uses when they're putting the information out to the consumer on race day to describe, you know, how that track is running. We were able to locate that data, and I stick that in the reports as a point of reference. But what we're finding is the track at Fair Hill, because of the way it was constructed, most likely, and the soils that they use there, it's not going to correlate with like what the Hong Kong Jockey Club uses for their information on any given day. So I think we're going to find that same thing, if I'm right, Mick, when we go back and start doing this on the cross country course as well. That Fair Hill, the oval particularly, and the renovated portions of the timber, because they didn't do it all. It's a tight track. It's a firm soil. The one time they did breeze on it last year, we took some clegg readings that day. They were coming back about 65, from what I recall, 65 to 67 that day. The jockeys and the trainers that were standing there were all very pleased with the footing that day. It looked good when we walked the track afterwards. Everybody seemed to be fine with it. We didn't have a Longchamp at the time, so I wasn't able to take those readings. But it's, as you move along, you can kind of tell how the clegg data just doesn't seem to really do much for us. We run into the same thing in the sports turf world. A lot of people want to use that clegg hammer when they go out and try to determine if a synthetic football field surface is safe from head injury potential, and they use a clegg hammer. It's not a very good indication of that, because a human head is obviously a lot bigger than the missile that's on that clegg hammer. And the way it's been described to me previously is when you drop that clegg, it just doesn't have enough oomph to it, enough mass to it to really tell you anything. Obviously, that's most likely the same case with the equine side of things. You're talking a rather large animal there versus a little tiny projectile. So I can see why the bowling ball, for instance, makes a lot of sense on how they're doing it. I'm actually intrigued about looking at using that on football fields, by the way, because I think it more accurately reflects what they're going to see. But it's mass. It's all about mass and trying to replicate what they're doing. So ongoing effort between us and Alison's team over in the UK this coming year. And we'd like to be able to add a few events here domestically in the US to be able to go out and test if anyone is interested in doing that. We'd probably like to do that at least on a limited basis this coming season, if it's possible, to just kind of see again how we can start building these data sets out a little bit more and seeing what we're dealing with there. A little bit about Fair Hill. I promised the guy from the state of Maryland I'd throw this in at the end here, just a little bit about that facility. It's a nice overhead shot of it. You can see they have the arena set up in the middle here for the 5-star event. The oval track, you can see where the timber actually extends back this way, kind of where the renovated portions of this track ended right here. The actual track extends right to there. So it makes this, it actually comes out this way, goes back and then crosses the oval here, comes out this inside chute and then hits back on the front stretch and ends right here at the finish line of the oval track as well. The eventing course is actually, at least this past year, they started here. They shot off on the side and kind of went down and around. They had a water feature over here. It winds back through the trees to another field back in here and makes a loop and then comes back this way. And they finished right up on the side of this pond this year. My understanding is they are going to redesign this course slightly for this coming season because they actually want to bring part of the 5-star event onto the arenas, is apparently what they're talking about now. So they're doing more in front of the main grandstand and things. I guess they think it's just gonna be a better flow for them. So it'll be kind of interesting to see how that ends up going. But one of the things that the guys at Fair Hill wanted me to pass along is they are hoping to be able to make this facility kind of a center for equine safety testing and research. They only run one race on this oval a year. So they're trying to figure out ways to make it a financially viable operation out there. So they are kind of starting to look for industry partners to do things with them, to hopefully really build out their testing and research operations there. And I think the Equine Sports Turfgrass Alliance, which Mick drug me into, they're hoping that we end up playing somewhat of a role on that out there. It's kind of a neat concept. It's kind of a unique facility because of the event load. There's not overly crazy. I think it does present some interesting opportunities that they may actually be able to do some of this stuff with it. So we'll see where it goes. It's a government-run operation, though, so you know how that can be. You're always one, administration change away from having a completely different way of looking at things. So I think the current governor in Maryland's there until next year, if I remember correctly. And the guy we do deal with is a political appointee. So again, that could make things a little challenging moving forward. But we'll see how it all works out. But so far, so good. It's been very interesting to be involved in, and you learn something new every day on it. So it's been kind of neat. So any questions about anything on my end? I appreciate your time. Thank you much.